All right, so the second lesson is applications of index laws, or the laws of indices, or the laws of exponents. So question 1 is simplify 4 to power 2 times 4 to power 2. So I'm going to use so right here to simplify, let's remind ourselves of rule number 1 of indices, that states if you have a to power n times a to power m, as long as the bases are the same, then you can simply add the exponents, so it will be a to power n plus m. So that was the first rule or the first law of indices or of exponents. So to simplify this is simply 4 to power 2 plus 2, which is equal to 4 to power 4. We simplify. So to simplify is to make it simple. You cannot go further than 4 to power 4. So that is end of the story right there. Let's go to question number 2. Question number 2 is evaluate. So it's the same question as number 1. The only difference is to evaluate, to find the value of 4 to power 2 times 4 to power 2. So that is what we're going to do. So first let's simplify, and that will be 4 to power 4. That is 4 to power 2 plus 2. And then to find the value of that, we multiply base by itself 4 times. So 4 times 4 times 4 times 4 times 4. 4 times 4, that is 16, and 16, and 4 times 4 is 16. 16 times 16 is 256. More often people try to get confused whenever they say 4 to power 4. They simply say that is equal to 4 times 4. No, that is not correct. So 4 to power 4 is not the same as 4 times 4. So let's get that into our heads. Is the same as 4 times 4 times 4 times 4, 4 times. So which is 16 times 16. All right. Let's go to question number 3. We need to simplify. So the first thing is to combine 2 to power 10 times 2 to power 3 in the numerator. So that is the same as 2 to power 13, because 10 plus 3 is 13 over 2 to power 8. And now applying the second law of indices, when you have a to power n divided by a to power m, as long as n is greater than m, then you can have a to power n minus m. So in this case, our answer will be 2 to power 13 minus 8, which is equal to 2 to power 5. End of the story. That is simplified. Right? Let's move to the next question. So the next question is to find the value, which is the same as evaluate. So it's the same question as in number 3. So we simplify this. That's 10 to power 2 to power 13 over 2 to power 8, which is equal to 2 to power 5. But we need to find the value. What is that equal to? So 2 to power 5. Remember, people, 2 to power 5 is not equal to 2 times 5, which is 10. No, that's not equal. It is equal to, rather, 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, and 2 times 2 is 4. So 4 times 4 times 2, that is 16 times 2 is 32. All right, thank you. Let's move to number 5. Alright, so right here we need to simplify the following expression and write your answer with positive exponent. Alright, so we go ahead and simplify this. So it will be 2 to the power 13 over 2 to the power 18. And to simplify this will be 2 to the power 13 minus 18, which is equal to 2 to the power negative 5. But we need to write our answer with positive exponent. So remember rule number 3 of exponent. Whenever you have a to the power negative n, that is the same as 1 over a to the power n, taking the reciprocal of a to the power negative 1 over negative n over 1 is the same as 1 over a to the power n, but the exponent become positive in the denominator. So right here it will be 1 over 2 to the power 5. That's when you write it as positive exponent. Alright, I think it's getting a little bit alright, so let's continue with this. It did not say anything whether we need to simplify or evaluate, but so let's just look. The final product is going to dictate whether you need to leave it in exponential form or you want to evaluate it. So right here it will be 10 to the power, it's going to be 2 to the power 13, all right, over 2 to the power 8 divided by 2 to the power 5. And if we simplify this, this becomes 2 to the power 5 divided by 2 to the power 5. So 2 to the power 5 divided by 2 to the power 5 is the same as 2 to the power 0. Yes, because 2 to the power 5, 5 minus 5 is 0. But if you look at it, this is the same number divided by itself. So any number raised to the power 0 is simply equal to 1. And so this will be rule number 4 of exponent, which I did not mention earlier. Any number raised to the power 0 that is equal to 1, because that number divided by itself is just 1. As we have seen here, 2 to the power 5 divided by 2 to the power 5 is the same number, so that is equal to 1, which is the same as 2 to the power 0. Alright, let's try number 7, evaluate. So we should come up with a single number. So right here, this will be 10 to the power 15, okay, over 10 to the power 8 times 1 over 10 to the power negative 5. And let's continue. So this becomes 10 to the power 7 times, now we can rewrite this by finding the reciprocal of 1 over 10 to negative 5, which is 10 to the power 5. And this become 10 to the power 12. So there's a mistake here. We should not, we don't need to evaluate. We need to simplify, because if you evaluate it, you're going to have a lot of zeros. So let's simplify. So it's going to be 10 to the power 12, and you multiply, that's going to be 1 with 12 zeros. Okay. So number 8, we need to find the value of x. So in this case, the left side of the equation here is okay. So let's simplify the right side. So this will be 5 to the power 8 times 5 to the power 6. This becomes as to 5 to the power 14. So right here we have 5 to the power 3 plus x is equal to 5 to the power 14. So for these two sides of the equation to be equal, x has to be 11, because 3 plus 11 will give us 14. So in other words, just set the exponents equal to each other. 3 plus x is equal to 14, and then we subtract 3 on both sides of the equation. So our x here is equal to 11. Alright, so that's the value of x. Alright. Well, this is the end of our lesson. If you have any question, please let us know. We'll be more than happy to provide you with more resources to deepen your understanding of applications of exponents.